This is the fourth part of our series on HDL Coder's custom reference design and IP core generation to target a custom FPGA board. The previous video showed how to register a custom board and reference design to populate the HDL Workflow Advisor. Now we are ready to target the design to it. So double check to make sure everything is set up on the path under Custom Boards, IP Core, UU Custom before you start Simulink. In Simulink, right-click on the AM Design subsystem and bring up the HDL Workflow Advisor. Now when we click on Set Target Device and Synthesis Tool and select IP Core Generation, our target platform is there. So we'll select that and Vivado as our synthesis tool. Everything else will be populated and we can run this task. Then we select the reference design and the fields are all populated so we can run this task. Then, moving to setting the target platform interface, where we will map our subsystem IOs to the reference design pins. For a generic reference design, you would specify which IOs get mapped to pins in AXI registers, but this reference design is set up custom, and we specifically mapped where each IO goes to, so we can just use the defaults and run this task. Then we defined the default as 125 MHz, which is what we had set our design up for anyway, so we can just run this task. After that, we can skip ahead to generate RTL and IP core and run to this task. This will run all the checking steps in between. This takes a bit of time depending on the size and complexity of your design. This generates the Verilog HDL and a bunch of reports you can use to see your resource usage, clocks, and so forth, and an IP core generation report. This has all the info you will need to integrate this core into the full design. We will have HDL Coder program the device too, so we can move on and create a Vivado project, which you can click on here to open in Vivado. Now if we open the block diagram, here now we have the IP core in the reference design. Now we can go and generate the bit stream, which takes a few minutes again depending on your design size. In this last step, we'll program the device via JTAG, which will download the bit stream and program the device. Finally, we can test the design running on the board. We've set it up to play some music from a mobile phone into the headset's microphone. The demodulated output is heard from the speaker. This video series walked through the steps for creating a reference design for a custom FPGA board, registering it in MATLAB, and targeting it using HDL Coder. The example was simple and focused on a Xilinx-based board, but the same approach applies to any type of design and board. Of course, the reference design creation step will vary depending on your FPGA vendor. You can find more detailed information on all of these steps in the product documentation, and a great place to start is the examples, since they walk you through practical applications in real scenarios.